So this is the feedback for section C and the questions about the skeleton code for target clear. First question was really well answered. There weren't any issues in terms of completing the missing parts of this hierarchy chart. You were identifying the subroutines correctly and giving the valid identifiers as you would find them in the code. So no issues with capitalization, spaces, additional arguments. You just literally provided the identifiers, which is exactly what you should do. And so people got the marks for that. The second question is about this convert to RPN function, which is definitely a function I think you need to be spending some time making sure that you're happy with in terms of the logic and how it works. Effectively, it takes the user's infix expression that they enter and converts it into an RPN expression in a kind of string form, I think. Just to remind about how you do that manually. So effectively it's doing the manual version conversion that we're familiar with of if we were doing it with number, the first operand, and then we'd jump over the operator, label the next operand, and if both sides of the operator were satisfied, then we'd come back and number it unless the precedence of the next operator was higher, which obviously in this case it is. So we're going to jump over that operator as well, number our third operand. Now we've satisfied both sides of this of the multiply, so we can number that 4. And now we've got both sides of the addition operator satisfied, so we can label that 5. And that leads us to our output string that we've got here. So the algorithm that's doing that is here, the convert to RPN, and I think there's a couple of things in here that are worth kind of pointing out. First, obviously, is the use of a dictionary. I think it's definitely worth you having a look at that and any past paper questions you can find as well, just to make sure you're happy with the kind of key aspects of the dictionary data structure. In this particular example, and in terms of dictionaries generally as well, of course, you've got this idea of key value pairs. And in this particular example, we've got the operator that's acting as a key, a unique identifier. And then we've got the value associated to that, which is just an integer value. And you can see, obviously, for multiply and divide, the value is higher for equal weighting compared to the addition and the subtraction. So we have a means now of determining whether one operator has a higher precedence or not than another. Okay. The other thing to kind of point out is this list here, which is called operators, and to make the connection here to the fact that this is acting basically like a stack. So a stack in terms of we last in, first out. So when we see, for example, its first use, when we have our first operator, we add it effectively to the top of the stack. And then when you look at any kind of instances where we remove an operator from the stack, so here and here, for instance, you'll notice that we always take in the count of what's currently the number of items in the stack minus 1 to get that last index. So we're always going to be taking out the last item to be added in. Okay, it's definitely worth you stepping through this algorithm using, some infix expressions, maybe a couple of small infix expressions like this, so you can see how this is actually working, how the dictionary is working. Effectively, you've got this stack, which initially our first operator to be added, if this was our expression, would be the plus symbol. And then we go into this while loop to kind of look for other operators that we need to ultimately move into this RPN string that we're going to produce at the end. So when we do get to the multiply, we end up with a situation here, and this is where you can see where we're sort of considering the precedence and whether or not we're going to apply the one that's already been added to the stack, in this case the plus, or whether we're going to add another operator to the stack and apply it sort of at the end. So in this particular example here's the reference to dictionary precedence. Our current operator that's already in the stack is the plus, and we know that this because we're getting that from the dictionary, we can look up the actual value here because that's what we're supplying in this plus operator. We'll go and get that value of 2 that's associated to that. And then if our current operator is the asterisk, so again, we're getting that directly from our dictionary, and we'd look up the value 4. And clearly, in this case, 2 is less than 4. So we're not going to be removing from the stack. We're going to be adding that asterisk onto the stack. And you can see in this walkthrough here, there's that initial placing of the plus operator onto the stack. And then the bit that we just traced here is where the asterisk ultimately then does get added, because it's of higher precedence than the operator that's already on the stack. So yeah, being happy with that and being able to sort of work your way through that, I think is going to be important, potentially for some questions that you might get on programming side, but certainly for maybe a theory question you get asked as well in terms of how it's working. So yeah, definitely useful for you to kind of step through that and see how it's working. Okay. In this particular question, it said how to handle operators of equal precedence. The masking answer doesn't really sort of focus specifically on that, really. So in terms of how I marked it, I gave 1 mark for the mention of the fact that we have got the use of a stack in the form of the operators list, to help ensure that we're applying the operators in the correct order. But actually, there is that check there to make sure that higher precedence operators are applied before lower precedence ones. And that was what they were looking for to get the 2 marks in this particular mark schema. Okay, although I'm not 100% sure it's a precise answer for this particular question, but never mind. What type of data structure is precedence? Well, that was an easy one, wasn't it? Because you could look at the identified precedence and look at its data type, and well, it's a dictionary. So there weren't many issues with that question. A lot of people got that one. This one wasn't well answered. So what type of iteration is used in convert to run? So in convert to, I think that's a typo there, isn't there? Which is so indefinite iteration, and really I've just put that in to highlight that terms that we're not really used so much on the course, but indefinite iteration equals things like while and do while versus definite iteration, which equals for and for each. Yeah, hopefully fairly easy to make the connection in terms of the definitions there. And then the final one is what algorithm does convert to RPN implement, and the answer to that was the shunting yard algorithm, which again I don't think you're necessarily going to be expected to know for the exam, but it's worth you having that awareness, and potentially could come up, although I feel it's unlikely. The next question was to describe the next function. Again, a really important one, I think, in this particular pre-release. It evaluates the RPN function. So once we've got it in RPN format, actually then processing it to produce a result of the calculation. The mark scheme for this one, to kind of show you what it looks like, was just being really clear about the method of operation here. And I gave the first mark for highlighting the fact that once it's in RPN, obviously we don't need the parentheses anymore. So there's no need for the brackets. So that was where the first mark point was. And then just sort of really describing how it's working. So obviously you push your operands 1 by 1 onto the stack. And when an operator is encountered, you pop the previous 2 operands that have been pushed onto the stack. You apply that particular operator to those 2 operands, generate a result, and then push that result back onto the stack. And effectively, you keep going until you've got an empty stack, with the final pop being the result of your calculation. So that would just been explained, and it was probably mainly on the second part of that answer that people didn't really go into detail in terms of describing how that stack is used and that process of pushing operands onto the stack, and then when you hit an operator, the popping of the 2 operands, the last 2 operands, and then applying that operator and pushing the result back and so on. Okay, sorry for repeating myself a bit there. What would happen if an invalid operation is attempted in this particular function? Here, just being really clear that the program would crash or terminate was what we're looking for, because there's no particular exception handling in place to handle it. But I think crash is the key word that we're looking for. And then what are the benefits of RPN expressions compared to infix expressions? I think this one's definitely worth, again, emphasizing and definitely been happy to explain with. And again, if we take, for example, this expression here, which is currently in infix form, if you were writing an algorithm that had to sort of parse this particular expression and evaluate the result, it potentially could be quite tricky, because you would need to obviously be able to keep a track in your algorithm as to where brackets open and where they close. You might need to sort of work out the results of inner brackets and then backtrack to apply them to results, results that calculated earlier on. And then you've also got to understand and make sure that precedence is applied correctly. So in this case, again, your algorithm would need to determine, in this instance, where brackets haven't been used, that the division needs to take precedence over the addition. So that potentially is quite a complicated algorithm to write and has quite a number of operations involved to do that if it's an infixed expression. Obviously, when we've got RPN, we haven't got the parentheses, so that's a big thing to mention first off. And we don't need to worry about precedence because we've got a definitive order in which to evaluate the expression, as long as we're using a stack to do it. And that's really what you need to be clear about. We can just, as we've described in the previous answer, push the operands on. And pop when we hit the operator and calculate the result and push back on. It's just eat, sleep, repeat. So there's no need for brackets and no need for backtracking or sort of any complex parsing parsing required to evaluate the expression. So it's going to be done more quickly as well. So being really clear about that, I think, is important. The question refers to use succession. Why might it be useful to use succession in a program like this for user input? So again, this idea of managing exceptions, that exceptions can be planned for by a programmer and should be anticipated. So in here, always good to use examples. So we've got that divide by 0 example that potentially could arise. And yeah, basically you want to be clear about the benefit of it. So that, stopping the program from crashing and allowing, the user to continue to use the program and maybe informing them of the issue that's arisen is kind of what we want to happen. So being absolutely clear about what the perfect exception handling is. And yeah, I think also being clear to the user as well about the fact that an issue has been encountered, but it's been handled. The example in this particular one was the catch, the divide by 0 errors that potentially the evaluate RPN could occur. Okay. Last one was well answered. This one was well answered, so didn't have any issues here. This one we did have an issue because a lot of you, I think, you've been so focused on the identifiers, you just immediately put the identifier of the list. That was which I think might have been targets, but off the top of my head, rather than the actual list method, which was the list methods were how you interact with the list. So and obviously we add to the list and we remove at a certain point in the list. So they were the names of the actual methods there. So that was why you dropped the marks. And the last question again was well answered. So I don't think there's any issues there. If you drop 1 mark or you got one thing wrong, then that was sort of 1 mark off the 2 that were available for this question. If you got them all right, you had to get them all right to get the full 2 marks. Okay. Question 13 is about the updates target. Implements the shunting of the targets down by, or maybe shuffle would be a better word to use there in that question. That we've sort of used more frequently in class, and people were happy again that was linear time. And depending on the number of elements in the target list would then determine the number of shuffles that needed to occur. So there are no problems there. Explain the purpose of regular expression. This wasn't well answered. And I think anything where you explain the purpose of, and with these regular expressions, really sort of breaking it down and getting into how it works. So people just gave a general overview about how it validates user input, which is kind of already in the question as well, to some extent. So I couldn't really give credit for that. So you notice that the mark scheme answer sort of goes through and it does kind of, line by line or part by part, really sort of explain what the different features of the regular expression are validating specifically. Okay, so being clear about that and obviously being happy with these different operators and this regular expression, again, is definitely something to look over in preparation for the exam. Okay. The next one was if you remove the plus operator. This was well answered. You just need to be really clear that you could only then match single digit integers, yeah, always good again to give examples. So i.e. 13 wouldn't be a valid input anymore. Okay, because we could only allow a single instance of a digit to be entered. So that word single is what I was looking for, really. And then C, explain why regular expression could be adapted to check the validity of mathematical expression, but BNF could. I quite like this question again, and again highlights why I think you should be going away and reading up on BNF and making sure you're happy, particularly with BNF compared to regular expressions, and why they are more powerful form of being able to kind of define syntax in languages. Yeah, regular expressions do not support recursion, or if you said that they've already, that the BNF does support recursion, gave you credit. And sort of linked in with that then is the fact that regular expression, you can't track the opening and closing of brackets. There's no way of doing that because regular expression has no notion of state. So I think being clear about those explanations would be important as well. So that's definitely another place to go, just do a little bit of additional reading around as well, I think. And the last one, difference between truncation and rounding. Again, I think I think maybe felt I was harsh on this one, but I think, again, explain anything like this, you could probably give an example for, just to make it 100% crystal clear you understand what you're mentioning and what you're discussing. So we're looking for words like truncation discarding, where rounding adjusts. And I think really being clear that the rounding focuses on may increase the final digit. And you know, the easiest and clearest way to do it was to then just back up your explanation with an example. And so obviously you can see this one here, truncated to 2 decimal places, what it would look like, what would it look like if it was rounded to 2 decimal places as well. Okay, so yeah, people that gave examples tended to get the marks on this question purely because the explanation of rounding in particular wasn't so clear. Okay, so just being really clear, when it comes to rounding, it's the final digit that could either obviously increase or be rounded down. Okay, so yeah, I think that's everything for section C, and yeah, that's the feedback.